Hello everyone, this is Rasta Goswami, and today I'm going to um, today I'm going to teach the new topic, which is quartile deviations. So sorry for the late. Yesterday I was quite busy, and this is my procrastination also that I didn't make any video. But next time I will try to be consistent. Not trying, I will be consistent. So here I am starting a new topic, which is quartile deviations QD. So interquartile range IQR is the difference between the value of the upper and the lower quartile in the series. So IQR measures the validity of the series in the central 50% limit. So quartile deviations, as we have studied earlier, what is quartile deviations and how to measure it. Now we are studying the deviations part. So we have already studied what is quartile distributions and other form of quartile. Now we are studying the quartile deviation. So in when the deviations comes, there are two kinds of thing which we need to measure, which is first one is absolute measure and the second one is relative measures. Okay, so interquartile range IQR is the difference between the value of the upper quartile in the series. IQR measures the variability of the series in the center 50% limit. Okay, so interquartile range IQR is the difference between the value of upper and lower quartile in the series. IQR measures the variability of the series in the central 50% limit, and thus absolute measures of IQR Q3 minus Q1. Relative measures of IQR or coefficient of IQR is Q3 minus Q1, Q3 plus Q1. So here says that interquartile range IQR is the difference between the value of the upper quartile. So we have already knowledge about how to calculate the quartile. Okay, so when you know that how to calculate the quartile, so first you have to know the measures that how to calculate a quartile. So once you know that while calculating the quartile, and all the quartile have the same formula. Okay, so it depends on the series, but quartile 1, quartile 2, it is the same, just a minor difference is there. Okay, so when you calculate the quartile, then the deviation part come, which is same as the range, where the absolute measure of IQR, which is Q3 minus Q1. Okay, so absolute may we are generally doing this only, and unit will be applied. Then relative measures of IQR, coefficient of IQR. So Q3 minus Q1, Q3 plus Q1. Okay, so quartile deviation QD or semi interquartile range is the half of the IQR. So quartile deviation QD or semi interquartile range is the half of the IQR. So absolute measures of QD, Q3 minus Q1 divided by 2. So quartile deviations QD is also called semi-interquartile range, is the half of the IQR. So interquartile range we can also say that semi-interquartile range or quartile deviations. So thus the absolute measures of QD, Q3 minus Q1 is divided by 2. Thus, the relative measures of QD, coefficient of the QD, so Q3 minus Q1 divided by 2, minus Q1 divided by 2, divided Q3 plus Q2, and here this is a relative or interquartile, so 2 must be divided. So to in order to calculate the relative value, so it is just a proof. Okay, So when we divide, so what will happen when it comes to the into it reciprocate? So when it reciprocate, then 2 will be cancelled out. So when the minus q3 minus q1 will be at the top, and at the bottom q3 plus q1. Okay. So here we will see that how to calculate the quartile, as well as we will see that according to series how it differ, and also how to calculate the relative and the absolute measure. So first we need to calculate the two measures. So here not all the observations will be taken. Like in the quartile, as we have studied that three quartiles is there, q1, q2, q3. So we will only take q1 and q3. Okay, so to calculate the q1, first is size of n by 4 plus 1. So why this is 4 written? So 4 is written because it is a quartile. I mean, you have to calculate the 4 part. So here the in the denominator there is a 4, and this all the formulas is similar to the how you are calculating the median. So which we have studied already. So size of n by 4 plus 1 term. Okay, so in the individual series or discrete series, plus 1 is there. Okay, so we put the value like n is what, number of observation, 1 2 3 4 5 6 7 8. So there are 8 number of observations, so 8 by 4 is there, plus 1 and nth term, and then when you calculate it, so 2.25 items will become. Okay, so once you have calculated the q1, then if the value is comes into the decimal, so we calculated q1 is equal to size of the second item plus 1 by 4th. We written 0.25 in the form of fractions, 1 by 4, which is 1 by 4 is what, third and second item. So 1 by 4 is like third, between the third and the second item, third and the second item. Okay, so when we written this, so when we simplified or calculate, so 1 by 4 will become, and when you divide it by the 4, so similar answer will become. Okay, so if you calculate the observation, so it is between the third and the second items. Okay, so 1 by 4th is like third and the second item. So 4 is second is what, like this is a second item. So of course the items will be in the third and the second, as we have studied in the medium when it comes to the decimal. So first you will see that this is the number of item. Okay, so first you can see that this is the second number of item. Now 0.5 is there, so 0.5 where it will come, 2.05, it is between the second and the third item. That's why the bigger items, like third item is written first, and then the second item, and whatever the decimal in the addition. So okay, so when the second item is what, 44, so you write the 44, then 1 by 4. And what is the third item, 47, so 40, you have to write the 47 minus 44. Okay, then 3 will come, 1 by 4 and 44. So to you have to calculate all the things. 44.75 works. So this is just a quartile. So in the quartile, of course, unit will be applied. So just calculate it. It is a simple method. So if you have good practice over the medium, so as minor changes are there, like despite of uh, 2 there is 4, and this and the multiplying into the size of observation is based on numbers of quartile. Okay, So here is lower quartile. So what is lower quartile? So lower quartile is size of 3 and plus 1/4 items. So upper quartiles here there is Q3. Sorry. So here in the Q3 items, you can see one difference, which is Q3 is 3 into and plus 1/4. Okay. So when you are multiplying it, so all the observation is written as it is, and then the value will become, then the values we can see that it is between the 7th and the 16th item. So as we have written already, so all the marks will be written, and the 65.75 marks is there. Then absolute measures of IQ are Q3 minus Q1. Right. So when you have already calculated the Q3 and Q1, so now there is a time to calculate the absolute measures of the IQR. So how to calculate the absolute measures of IQR? First you have to subtract from the highest value, which is the in the quartile there is only three value, Q1, Q2 or Q3. Q2 is the middle value, so there is no work. So in the deviations, what we have to do, the even in the range we have seen that the highest, subtract the highest value to the lowest value. So the highest value in the quartile deviation is Q3 and the lowest is Q1. So put the value and whatever you got, so along with the unit which is marked. So this is the absolute measure. So in order to calculate the coefficient of the IQR, so what you have to write, Q3 minus Q1 and Q3 plus Q1. Okay. So write all the things. So in the subtraction part we have already calculated. In the additions we calculate, and then whatever it get the answer. So just divide it, and then you got the coefficient of the IQR, which is 0.91. Well, dividing 21 divided by 110.5. Okay, you got it now. Now there is a semi, and not only calculating the absolute and the coefficient value, you should also calculate the semi IQR, interquartile range, and absolute measure. So where we calculate the Q1 to Q2, and the formula only differ where you have to divide by the 2. So here the interquartile, I mean the mid value will be also come, that from the mid value how the values are deviated. So it calculated by the interquartile or semi IQR absolute measures of the QD. So here where we write the values, so while dividing it we get the 10.5, which is a middle value. So coefficient of QD, Q3 minus Q1, Q3 plus Q1, and which also got the 0.19. Okay. Now we have, so it is the coefficient of QD. Okay. And here is the coefficient of IQ. Wait a second. This is also a coefficient of IQR and measures of IQR. So here, well, after the calculating the Q1 and Q3, so we calculate absolute measures of the IQR, then coefficient of the IQR, and then we calculate the semi IQR, and then at last but not the least, coefficient of QD. So semi IQR absolute measures is calculated, then there is a coefficient of QD, which is Q3 minus Q1. Okay. Now we will calculate the discrete series. So what is discrete series? Where frequency is there, but the marks or the observation is not in a series way. Okay, not in the lower limit and upper limit kind of a way. Okay, so the values are discrete. So here the frequencies is also there. So remember that when we calculate the median, so CF, cumulative frequencies, is also there. Cumulative frequencies are of two types. Like, first you have to edit all the values and then you come to decreasing the value. Okay, so it is like a descending order. And on the other hand, there is also a cumulative frequencies where the values are added successively. So this is like ascending order. Okay, so when you have written all the values like 2, 5, 14, 35, 45, 50, and here is 2, 3, 9, sorry, 21, 10, 5, and here is 10, 14, 16, 18, 20, 22. Okay, so all the values have written. F is equal to 50. Now what you have to do is that first, and the summation of F is equal to CF. Now first you have to calculate the lower quartile, which is Q1, is the size of the n plus 1, which is fourth items, and then Q1 is equal to size of 50. So here n is what? There is only difference in the discrete series where the value of n will be changed. In the individual series we calculate that okay, how many numbers of observation is there. Here we will calculate the number of frequency, what is the total frequency, or you can also take the last of the CF. Okay, so when we have calculated the value, so all the things are the same by 4, and because it is q1, so nothing will be multiplied by the formula. So what we get 6 12.75. So here the things are changed in the individual series. We, after that we take sixth item, second item, plus something which is comes into the decimal, and then we calculate that this is mid value of the this series and this series. But in the discrete series, I think it is the one of the easiest method. So here whatever the observation is, it is 12.75. So first see that where the 12.75 will come into the series. So here is 14. So the value which is closest, but the value which is closest, and the value which is closest and greater to the items, number of items, so that will be the q1. So here is a 41, and what will be the answer? It is 16. So 14, and here 9, and the observation is what? 16. So this is the q1. Okay, similarly in the q3, the number of items will be same. 3 will be multiplied because this is the third quartile. If the second quartile is there, then 2 will be into. But here we just need q1 and q3 according to the formula. So when we write all the things, so 38.25 will become, so 38. So which is the value which is closest but greatest to the value? So 45 is there. 35 is no matter closest, but we have to get the value which is just above to the value. So here is 45. So what is the observations value? Observations value is 20. So 20 will be the answer of the Q3. Now we have q1 and q3 value. Then we will calculate the absolute of IQR. Then we will calculate the relative or coefficient of IQR. Then semi coefficient of IQR, and at last we will calculate the coefficient of QT. Okay, so absolute measures of IQR is Q3 minus Q1, which is 20 minus 16, and we get the 4 marks. Now here is coefficient of the IQR, Q3 minus Q1 and Q3 plus Q1. So while calculating all the things, so we get the fraction 0.11 marks. So this is the coefficient of IQ, or absolute measures is 4 marks. Then we have absolute measures of QD, and absolute measures of QD, and you can also say semi measures of the coefficient. So absolute measures of the QD, quartile deviation. So we get the medial value, that from the medial value how it is deviated. So 2 marks. Okay. Then coefficient of the, so it is because it is the absolute values of course the values, unit will become at the unit only. Then we have coefficient. So in the coefficient we calculate as it is the same value, so which is 0.11. So it all similar to the first one. So not the first one, in the first one value is different. Here you are calculating the medial value of the absolute, and in the coefficient you have to do the same. Okay, but in the absolute of the measures of the QD you have done the same, which is approximately the half of the absolute measures of the interquartile deviation range, sorry, interquartile range, which is the half of that. Half because what? Because we are taking the Q3 and Q1 and it is between that. So the value, of course, the deviations will be half of that, half from this and half from this. So yeah, this is the thing, and in the coefficient the same format will be applied. So 0.11 marks, and not marks because marks will be not there. Here I have written marks. Okay. So do remember that in coefficient, when you are calculating the coefficient or the relative measure, so never write things in the marks because it calculating the deviation. So if we are considering the unit, then it will not come exact. Okay. So that is why unit will be ignored. So never write unit in the coefficient and the relative value. Here then we have continuous series. So 0, 10. So in the continuous frequency is there, but in the here class interval is also involved. So class interval is there, number of student is there, and we are calculating the CF because it is similar to median. So CF is very important because it is involved in the formula, especially in the continuous series. There is another formula similar to median where the in the formula also CF is involved. Now we are calculating the lower quartile. So here what is the difference? Plus 1 is not there, unlike in the discrete or the individual series. Plus 1 is there, but here in the continuous series and by 4 directly. Okay. So while putting all those value we got 10th item. So there is no decimal, but even if it is decimal or not, we have to put this into the formula, which is the continuous series formula. So here 10th is written. So 10th item, so what is the class of that? So if the 10th is there, so first see that uh, similar to the discrete series, first see that which is close to the 10 and greater to the 10. So here is 13. Okay, so here is 13. So which is the class of that? 10 to 20. So here is the quartile 1 class. Quartile 1 class is 10 to 20, where then we put this into the formula where L1 plus n by 4 minus CF divided by frequency into I. Okay, so here we have seen that in well taking the Q1 classes, so we can get the value like in the CF the frequencies is what, 8. So here we put in the place of frequency 8. Then CF, so CF is first we will calculate the frequency and class through this, but in order to take put into the formula we will take just above the value. So here just above is 5. Okay, so and then 10 plus and what is the lower limit of the class? So lower limit is 10, so we put 10. Then the n by 4 is the quartile deviation one, whatever the answer it comes. So just write is as it is, then subtract it by CF just above the actual CF. So this is the 5. Okay, then in the frequency it is there, so it is followed by the same class and frequency only. So here is 8 is written, and then what is the interval of each and every series. So here we can see the 0 to 10, 10 to 20, 20 to 30. So the class interval is 10. So if the series is not equally divided or open ended, so must convert the series into the close ended and equidistant same interval of the series. So then only it will be possible to further go. Then put the all the values, what we get, 5 into 10 and by 10, those cut the values, and what you got, ultimately you got q1 is equal to 16.25 marks. So this is the value from continuous series. It is quite lengthy due to the formula. Then to calculate the upper quartile, we have to do the similar from the Q3. Here is one difference, which is we have to multiply it by 3, and as you can see that 9/4 is the same. And when you have calculated is 30, the items will become, it is not like the items will be in the whole number, even if it is a fraction. So just see that what is the closest. So even in the fractions there is no such difference, so 30 items will come. So in calculation wise 29 is close, but you have to take the greater value, so 36 is the answer. So here when you are taking the 36, so frequency would be the 7, and 30 in 30 to 40 will be the Q3 class. Okay, so this is the class. Then put the lower limit value 30, and this is the value in the n/4 CF just above 36. So just above is 29. Then CF we got. Frequency, what is the frequencies? Frequency is 7. Class interval, check the class interval, 0 to 10, 10 to 20. So class interval is same as it is 10. Then put all the values. So here, as I said, put all the values, and do calculations carefully, because my calculation is not that good, so still I'm trying. So calculate the, put the all the value in together. 30 plus 1.42 and 31.42 marks will become, okay, it, the marks will be there. Then what you need to find out, you need to find out the absolute measures of the IQR, coefficient measures of the IQR, then absolute measures of the QR, and absolute measures of QR. Okay, so absolute measures of IQR, so we have calculated the 15 17 marks, 15.17. So here the Q3 and Q1 is there, and well subtracting this will be the answer. Then coefficient IQR is well subtracting and adding the values, and you got the 0.32. Then we have for the QD, absolute measures of the QD, Q3 minus Q1 divided by 2. All the values will be there, and where you're subtracting it, then 0.33. Okay, so here the coefficient value there. Then absolute may, here what the difference is, um it will be also divided to 2. So whatever the answer is, just divide by 2. So this will be the answer, and of course unit will be there, and the coefficient there is no unit, and the formula and process is the same, and get the same answer as it is, the coefficient of the IQR, okay, interquartile range, and this is the coefficient of quartile deviation. Now we will see what is the merit of the QD and what is the demerit of the QD. Then we will start the median deviations. Okay. So first is, it is easy to understand and simple to calculate. As we can see that there is nothing such complex process or rigidly defined difficult structure of the methods are there. Then QD can be calculated in case of an open ended series. So QD can be calculated, okay, in the case of open ended series. I mean that it can be calculated by open-ended series because we are not taking each and every observations, even it is middle, but we are just we don't have the need, as in the range there is a need of lower limit in the first observation and upper limit in the last observation. But here the value can be anything, so it is not necessary. Then QD is useful when the extreme value likely to affect the result. So QD is useful where the extreme here the extreme values, it is a good measures where the extreme values are not that effective. So if the extreme value will be involved, so here many values are not taken, and CF is there, frequency is there, so many things there. So the role of the X observation is quite low because the other things are also important. So because of the other things is also important, QT is not that effective towards the extreme values because they are not taking so much considerations to the X observation. Then QD is useful when we want to know the variability in the central part of the series. So if we want to see that what is the central part variability like Q3, Q1, it is all the center value. So when you want to know the central deviation, then QD is the good measure. Then we have demerit of the QD. So QD ignores the half of the observations of the series at the end. Okay, so QD ignores half of the observations of the series at the end. QD ignores QD, as you can see that QD is not taking all the observation, even Q2 is not involved, so just ignores half of the observation. There are so many observations which is left out and there is nothing to use. Then QD is not based on all the observations of the series, so as we can see that it is just taking the half of the observation, the middle part only. So it is based on all the observations of the series, and QD it is not involved. Okay, then QD is not applicable to further statistical analysis. Of course, anything which is easy to calculate, generally they are not useful for further to analyze or something like that because this is a basic method and there are so many loopholes, so it is hard to understand it. So here the quartile deviation is completed. Now we will start the median deviation in the next video. So till then, stay tuned, do like and share, subscribe, and also share my videos to your friends or anyone who is really needed. So till then, take care and bye bye. So I will meet you in the next video. So have a nice day.